Hello everyone, we are from FB2 Group 3. We will explain to you about the Newton's method. Newton's method is an open root finding method for a nonlinear function. We will input initial s value and solve to obtain approximate root value. It is derived from Taylor series expansion. This is the formula to get the roots, which is xn plus 1 equals to xn minus fx over f prime x. We will run this formula through multiple iterations to obtain the root.
Okay, so now we are going to apply the Newton-Raphson's method into Excel. First and foremost, we have to set our function and find its derivative. So first and foremost, our function is x squared minus 5x plus 4. And the derivative is 2x minus 5. Okay, so then we're going to write down our 4 headers, which is iteration, x current, fx, and differentiation of fx. So under the first iteration, the first cell under iteration, we're going to write down 0 and set a value of x, and then write down the coding for our function. So in this case, which is x squared minus 5x plus 4, we're just going to replace our x with the cell that contains our x value, which is in this case g8 to the power of 2 minus by 5 times g8 plus 4. Alright, so then the derivative, we're going to do the same thing. Insert the formula of the derivative into the cell beneath differentiation of fx. So 2 times by our x value, which is g8, and minus 5. Okay, so as we all know, our formula is x value minus by our function divided by the differentiation of the function. So we're going to just put in that formula into the cell beneath our first x value. So all we have to do is write down g8, which is the cell that contains our x value, minus by h8, which contains our fx, and divided by I8, which contains our differentiation.
So as for the results, we should start with putting in the x values, and our Excel will calculate for us our fx and also our f prime x values. So let's start with the first iteration. So we can select all of the columns and drag them down until the 12th row so that we will get 12 iterations. So after it has calculated for us, if our x value is decreasing, then it should be fine. However, if it is the opposite, then we should use a better starting point. Now, the root of the equation will be the value of x when it starts to become constant. So in this case, it is 0.999992.